Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and the ACT. However, I'm here today with the 2024 copy of the AP Precalculus free response questions. Now maybe you just took the test this year, or maybe you're watching in the future and you're prepping for an upcoming version of the AP Precalculus exam. Either way, my goal in this video is to break down the free response questions and to teach you how to answer them. Question 1 says the figure shows the graph of the function f on the domain negative 3.5 to 3.5, and they give you the points on the graph, and then they give you this other function g. So the first thing we're going to do is then we're going to plug this function into our calculator. Y equals 2.916 times 0.7 raised to the x power. And that's going to be our y1 function. And now let's go to the question. A says the function h is determined by h is equal to gof of x, or g of f of x, and find the value of h of 3 as a decimal function. So here's how I'd show my work. I'd say h of 3 is equal to g of f of 3. Now we have the graph of f, right? What is f of 3? Well, 3 is the input for the x value, so then f of 3 would equal 1. So somewhere on the exam I'd showcase that f of 3 is equal to 1. So then this would equal g of 1 then, right? I'm replacing this into the function. So what is g of 1? G of 1 basically requires me to go into my function and just plug in 1 for x. So there's a couple ways I could do this. Because I've already graphed this function, I could actually just go to the table and search up the corresponding value. So the corresponding value in the table would be 2.0412. Or if I wanted to go into the function, I could literally just plug it in like this into my calculator, 2.916 times 0.7 to the first. And I don't have to write to the first because that's the implied exponent, and get that answer there. Or if it's something more complicated, I could go to vars, y-vars functions y1, and I want to plug in the number 1. And any one of those ways I get my answer is 2.0412. Remember, 3 decimal places. So this is 2.0412. I could end with the 1 if I wanted to. Now for part 2, find all values of x for which f of x is equal to 1, or indicate that there are no such values. So remember that f of x is just another way of saying y is equal to 1. So basically, I'm looking for this graph where the graph is going to cross the line y equals 1. Well, it crosses at 3 different points. I get f of negative 3 is equal to 1. I get f of 0 is equal to 1. And then I get f of 3 is equal to 1. Right? So then how would I answer my question? I would just say x is equal to negative 3, comma 0, comma 3. And that would earn me the full credit. Part B just asks about the function of g, and it says find all x values for which g is equal to 2, or indicate that there are no such values. So I'm going to set this g equal to 2. So here's how I do my work manually. 2.916, 0.7 to the x. In order to solve first, I'm going to divide both sides by 2.916. The next thing I can do to manually solve this is I could take the ln of both sides. So then I get ln of this thing is equal to the ln of this thing. Now, one of the rules with natural logs and other logs is if you have an exponent, you can bring it down to the front. Now that I have these two sides equal and I want to isolate the x, then I'm just going to divide both sides by ln of 0.7. So obviously they'd want a decimal approximation, so then I would plug that in my calculator. However, let me show you a much simpler way to do this on the calculator. So then we're going to go to our graph function, right? And we're trying to find another point where y is equal to 2. So then I'm going to just graph y2 is equal to 2, and then I'm just going to graph this and see where the two lines cross each other. So I see where the blue and the red cross. So I'm going to go to second, calculate, and then I'm going to calculate the intersect. Now on the TI, they just want you to hover close to where the 3 points are. Here they want a left bound and a right bound though, so I'm just going to do that. And it says the intersection is 1.057. So that would be the same thing as if I plug this into my calculator x is equal to 1.057. Part 2, determine the end behavior of g as it increases without bound. So x increases without bound. This is very much like the sample test that I did earlier, but this is asking for the limit as x approaches infinity. And so you'd want to plug in your function here. And notice that this is an exponential decay graph. An exponential decay graph has a base less than 1 but greater than 0. And whenever you have an exponential decay, your limit as x approaches infinity becomes 0. Now you can look at this on your calculator too and see that if you just kept going further and further to the right, you see that the y values get really, really close to 0 as well. Part C asks you to determine if f has an inverse function. So here's the graph of f. Remember that a function is invertible if it passes the horizontal line test, and we see that it does not pass the horizontal line test, aka it is not 1-to-1, right? There are multiple x points for a single y point. So for part 1, all you need to do is answer no. F does not have an inverse function. Now for part 2, I'm just going to type it out just to save myself some of my handwriting here. But basically, because the function of f does not pass the horizontal line test, therefore it is not 1-to-1. And if a function is not 1-to-1, then you cannot find an inverse function. Something like that would get you full credit. All right, question 2 says, on the initial day of sales for a new video game, there are 40,000 units of that game sold. And then 91 days later, there's 76,000 units of that game sold that day. And then they want us to figure out a function that matches this logarithmic function. Okay, so we're going to use our calculator here. So we're going to calculate a log regression. What we're going to go to do is we're going to go to Stat and then Edit and put the numbers into L1 and L2. Notice how the question said that it's in terms of the number of units sold in thousands, so I don't need to plug in 40,000. And then what we're going to do then is we're going to go to second quit, and then we're going to go to Stat, Calc, Linear Regression, that's 9. And then I can store my equation vars, y vars, number 3, because I used the first 2 for the first 2 questions. So notice that when I did this, I got not a number. And so this might have been a really tricky part where you're like, what the heck, what do I do here? But notice that on day 0, right, if I were to plug it into a normal log regression, that would not work because I cannot take the ln of 0. That's outside of the domain. So notice how they shifted everything over here. So technically speaking, if you plugged in 0 here, you'd actually get in 1. So that's what we're going to do then is we're going to shift our values over by 1 so that we can plug it into this equation over here. So then back to this question, I'm going to go to Stat, Edit, and then instead I'm going to shift it over 1 day so that I can actually calculate a regression. Let's see if will it let me do it. No, I'll just go here, Calc, Linear Regression, and I'm going to store it into y bars function 3. And now it actually works, right? So my A is 40 and then my B is 7.961. Now that I've come up in this equation, I want to verify that it works by going to my calculator. Notice how I stored it over here, but this is not the right equation, right? It should be x plus 1, so let me go ahead and fix that. And then make sure your window is correct, right? So it goes from 0 to 91 for the days. And then my y max is around 76, so I just went up to 100, and I'm going to hit graph. And so when I plug in 0, I should get out 40. Let's see if I do. I do get out 40. And then when I plug in 91, I should get out 76. So I'm going to trace, and then 91, and see if that works. And I got 76. So I did do my function appropriately by shifting everything 1 over to the right. So it looks like I jumped the gun on this question though, because part 1 is just asking us to write 2 equations that can be used to find the constants. So let's do that then. We're going to plug in these numbers here, and then we're going to set them equal to 40 and 76 respectively, right? So the first equation would be 40 is equal to a plus b times ln of 0 plus 1. That'd be your first equation. And then the second equation would be 76 is equal to a plus b ln of 91 plus 1. So then now we can move on to part 2, which is saying find the values for a and b. Well, this first equation is really easy to simplify because ln of 1 is 0. So then the first equation simplifies to 40 is just equal to a. Now we can actually plug that into the second equation. 76 is equal to 40 plus b times ln of 92. So then solving this, we get 36 is equal to b ln of 92. We got that by minusing 40 from both sides. And then finally, we get 36 divided by ln of 92 is equal to b. So we can do that to check our work also. So second quit, 36 divided by ln of 92. And let's hope that I did this right. And I got 7.961. So that's a simple algebraic way of solving this equation without using the log regression. Part B says use the given data to find the AROC, the average rate of change of the number of units of video games sold from 0 to 91. So then the way I show my work then is I write this g of 91 minus g of 0 over 91 minus 0. And then we know that g of 91 is equal to 76. We know that g of 0 is equal to 40 over 91. And then I'm going to plug that into my calculator. That's basically 36 divided by 91. And that's 0.396. Going to round up the third one. And then always remember to include your units, right? So this would be thousands of units per day. So writing this out would be enough to get the credit for showing the computations. Part 2 says use the average rate of change found in Part 1 to estimate the number of video game units sold on day t is equal to 50. So then they're asking us to do a linear approximation here. So then we can say y is approximately equal to 0.396. Remember, your average rate of change is just another way of saying slope times t plus your starting point. What was our starting point? Our starting point was 40. So then if we plug in 50, then we could say y of 50 is approximately 0.396 times 50 plus 40. And then we're going to go ahead and plug that into our calculator. And so we get that's 59.8. So we can say 59.8 thousands of games. Another way you could do this is if you wanted to plot the regression line into your calculator, you could use this to make a linear regression and plug it into your calculator, but you could also do this by hand. All right, part 3 says let A of t represent the estimate of the number of units of video games sold in thousands using the average rate of change found in part 1. For A of 50, it can be found that A of 50 is less than G of 50, and explain why in general A of t is less than G of t for all t where zeros between t is less than 91. So this is kind of hard to parse out. So let me explain what they're saying basically with the shape of the graph. So if I were to graph the equation that we got for part 1, we basically have a log graph, right? And then when we're finding that secant line, we took these 2 points and we basically created this line that goes between these 2 points. Now, because the graph of ln is concave down, this secant line approximation that we made would always underestimate the actual value in between these 2 points. Now, this doesn't work after 91 and before 0, but in this case it works in between these 2 points. So then we just need to write this out using a complete sentence. So in order for you to get the full point here, I think you need to say something about how G is concave down, and then you'd need to say that the secant line is an under approximation for all the values between 0 and 91. So look at this weird pitchfork E that I have. This is just my fancy way of saying T is between 0 and 91. Part C says the makers of the video game reported that daily sales of the video game decreased after day 91. Explain why the error in the model G increases after t is equal to 91. So let me resketch the graph here. And so basically, after day 91, the log graph by itself continues to increase. Even though it doesn't look like it's increasing, it is increasing for all t values. Now, if the true value starts to decrease after day 91, you can see that the value of our model is going to start to get further and further away from a decreasing value over there. So we need to be able to explain this in a complete sentence.
The graph of g of t will continue to increase for all values of t greater than 91. If the true value of daily video game sales actually decreases, then our model will continue to deviate from the true value, thereby increasing the error.
So here we have question 3. I love how on this AP exam they give us a picture and then they say, note, figure not drawn to scale, as if this picture is supposed to help us figure out what's going on. Anyways, let's read the question. It says, the tire of a car has a radius of 9 inches. A person rolls the tire forward at a constant rate on level ground, as shown. Point W on the edge of the tire touches the ground at time t equals half a second. The tire completes a full rotation, and the next time W touches the ground is at time t equals 5/2 of a second. The maximum value of W above the ground is 18 inches. As the tire rolls, the height of W above the ground periodically increases and decreases. So we want to model this function then. So if it starts on the ground, we can use the point 1/2, 0 for j, right? This is where it's touching the ground. The question tells us it goes up to 18 inches. So then this midline over here would be 9 inches. That's halfway. That corresponds to the radius of the tire, by the way. And then 0 would be the ground over here. Now the question says it takes a full revolution and then hits the ground again at 5/2 of a second. So by subtracting these two, we can understand that the period of the sinusoid is 2 seconds across. So then this p would occur after 1 second. The max value occurs at 3/2, 18. And then if we want to figure out this point, then this point would be 1, 9, right? It's halfway between 1 and 3/2. So basically, every dot on this sinusoid is a half a second apart. So then this would be 0, 9. And then this f would be -1/2, 18. Now, reading this question, right, it never says that none of these things can be negative. So we can start here at 0, or we could have started here at 5/2, or we could have moved it back and forth. Here there's no absolutely right answer, as long as we understand that it's a periodic function and find something that is a reasonable approximation. Then part B says let's find A, B, C, and D. So how do we find A, B, and C, and D? A is the amplitude of the function, which is defined as the distance from the midline to the peak or the midline to the bottom. So A would be 9. C is the horizontal shift. So normally a sine function starts here and goes up, and it would start at 0. This one actually starts when t is equal to 1, so it has shifted 1 to the right. So in this case, my C would be -1. D represents my midline, which is 9. Everything's shifted up 9 units. And to calculate B, we take our new period, and then we set that equal to 2 pi divided by B. B is also known as our frequency, right? So our period is 2 seconds across, and so 2 is equal to 2 pi over B. And so then if we were to solve this, it'd be 2b is equal to 2 pi. Therefore, B is equal to pi. Now, this is just one of many possibilities of answers here. If you got a separate answer and want to share that with me below, feel free to share that with me and I'll check if you're correct. Part C tells us that the t-coordinate of K is T1, so this is T1 here, and then P is T2, and then they want us to figure out which one is true. So from K to P, it is increasing, so it would be either A or C, and then the function is positive, right, because all our values here are above 0, so then H would be positive and increasing. And then part 2 says describe how the rate of change is changing on the interval. Note that rate of change changing is another way of describing concavity, and between K and P, the shape of the graph is concave down. So then let's write this in a complete sentence. So for this question, all you got to understand is concave up represents an increasing rate and concave down represents a decreasing rate. Okay, question 4. This is all the computations without a calculator. So part 1 says solve for g of x is equal to 10. So I'm just going to plug in 10 over there. 10 is equal to e to the x plus 3. I don't need to write the exponent. Now for us to get rid of this e, we can convert to log, or we can take the ln of both sides. So then ln of 10 is just equivalent to x plus 3. And then we minus 3 from both sides. So ln of 10 minus 3 is equal to x. So then that would be your full answer there. For part 2, it says solve for h of x is equal to pi over 4. So we plug in pi over 4 for h of x. So arc sine is another way of saying sine inverse. So remember, for sine inverse, we're plugging in the ratio of sides and this is the angle that we're talking about. Or another way to think about it is we could just take the sine of both sides. So we'll take the sine of both sides. The sine cancels out the sine inverse. So sine of pi over 4 would then equal to x over 2. Well, what is sine of pi over 4? Sine of pi over 4 is just square root of 2 over 2, if you remember your unit circle. And then here, if we just want to solve for x, we just multiply both sides by 2. So x is equal to radical 2. So part B asks us to rewrite j as a single logarithm without negative exponents in any part of the expression. So the first thing we want to do before we even try to combine these is we want to rewrite this. This 9 is a coefficient. Remember that if you have a coefficient, you could bring it to the argument of your log. So this is equivalent to minus log base 10 of x to the 9th. Now the rule with addition in logs is if you add the two logs, you can combine them into a product, and then minusing makes it into a quotient. So if I wanted to rewrite j of x, it would be log base 10. Anything with a plus goes in the numerator as the product, so 8x to the 5th times 2x squared. And then anything with the minus goes into the denominator. So now we want to simplify as much as we can, so 8 times 2 is equal to 16. X to the 5th times x to the 2nd is x to the 7th. And then we rewrite this as x to the 9th over here. And so I have 9 x's in the denominator, 7 in the top, so then I can rewrite this as log base 10 of 16 over x squared. Now I could have rewritten as x to the negative 2 on top, but the question tells me no negative exponents. So this is the simplest form here. Part 2 says rewrite k as a single term involving tangent of x. So then we got to remember our Pythagorean identity first. So remember that sine squared plus cosine squared is equal to 1. So then if we were to rewrite it, we would get cosine squared of x is equal to 1 minus sine squared of x. So that helps us a little bit. And then also remember that secant can be rewritten as 1 over cosine of x. Secant is the reciprocal of cosine, not sine, right? So let's do some plug and chug then. I know that my 1 minus sine squared x can be replaced with cosine squared of x. I know that my sine is just a sine, and then my secant can be rewritten as 1 over cosine of x. And then this cancels out with one of these cosines, so then I'm left with cosine over sine. Now if you remember what cosine over sine simplifies into, that simplifies into cotangent, and then cotangent is also the same as 1 over tangent of x. So question C gives us a complicated looking function m and asks us to find all values in the domain of m that yield an output value of 0. Well, an output value of 0 just says plug in 0 for m of x, so that's the easy part. Now how do we get to this x? Well, to get rid of this how do we get to this x? To get rid of this inverse cosine, we're going to take the cosine of both sides. And so we get cosine of 0 is equal to tangent of 2x. Now remember that cosine of 0 is equal to 1. If you need to draw a little unit circle for yourself, you can do that. This is where 0 is, and then cosine corresponds to the x value on the unit circle. And so we're looking for values of where tangent is equal to 1. And notice how this question says find all values in the domain. So where are all values where tangent is equal to 1? Well, it's equal to 1 at pi over 4. It's also equal to 1 at 5 pi over 4. And then if we keep going on and on and on and on, you'll see that tangent is equal to 1 for all values of pi over 4 plus pi times k, where k is an integer. This is my fancy way of saying k is an integer. So if you remember the period of pi, this should make sense. Otherwise, you could also write pi over 4 plus 2 pi k and 5 pi over 4 plus 2 pi k. That would also be sufficient. And then we want to divide both sides by 2. So then you get pi over 8 plus pi over 2k. So these are all values that would yield an output value of 0. So a quick overview of scoring. Each of these questions is usually worth 1 point for a total of 6 points per free response question. The only exception would be this sign question, right? So in part A would be worth 2 points. Part B would be worth 2 points as well. I don't know how they're going to figure out the distribution of those points. But remember, for the other free response questions, if they ask you to justify, you need to use the appropriate precalculus terms and write incomplete sentences using proper grammar. Thank you so much for watching this video. I did my best to break down these questions using a couple different methods, but there are many other methods out there as well. So if you want to verify one of those methods with me, or if you have any questions or comments you'd like to add, feel free to leave them below.